Let us start. Let us start this beautiful day with a beautiful greeting. A beautiful life does not just happen, it is built day by day. Good morning to all present here. Today I, Ashdeep, student of BSc Math Honours,
And I, Neha Thakur, student of BSc Mathematics Honours, University of School Sciences, are here to be host of this event. Now let us firstly welcome our Honorable Dr. Deepak Vasan, Additional Director of National Institute of Electronics and Information Technology. Dr. Anita Vadraja Ma'am, Scientist D, National Institute of Electronics and Information Technology, Chandigarh. She has done MTech in computer science and she has more than 25 years of experience in teaching, software development and IT projects and subject expert in AI/ML and blockchain operating system and databasing. Head Department of Mathematics, Dr. C.P. Gandhi sir, Head Department of Life Sciences, Dr. Simranjit Kaur, and Head Department of Computer Software Engineering, Dr. Pooja Sharma.
now we would like to request Head of Department of CSC Pooja Sharma Ma'am, Head of Department of Life Sciences Simar Ma'am, and Head of Math Department Dr. C.P. Gandhi to please welcome our honorable guest Dr. Deepak Vasan for the floor of welcome.
Thank you so much, sir. The beauty of mathematics is that the more you know, the less sure you are about it.
So today we are here to celebrate the National Mathematics Day and Martyr Day. As we know that due to COVID-19, our Mathematical Day celebration has been delayed. So now we are here to celebrate this event.
We celebrate National Mathematics Day on 22nd December every year to mark the birth anniversary of legendary Indian mathematician Srinivasa Ramanujan. He was born on 22nd December 1887 and died on 26 April 1920. At a very young age, he showed the sign of unfold genius of his contribution regarding fractions, infinite series, number theory, mathematical analysis, set an example in mathematics, and mathematics used in various fields like physics, chemistry, and engineering.
Now we would like to invite Head of Life Sciences Dr. Simranjit Kaur Ma'am to please join us straight for the introduction of our honorable chief speaker Dr. Deepak Vasan sir.
Good morning, everyone, and a very warm welcome to all of you. As today, on behalf of University School of Sciences, Ratan Bhara University, we are celebrating National Mathematics Day. I would like to start with the few famous quotes by renowned mathematicians all around the world to know the magic of the mathematics. Albert Einstein quoted that pure mathematics is in its way the poetry of logical ideas. As far as the laws of mathematics refer to reality, they are not certain. As they are certain, they don't refer to reality. So, according to William Paul Thurston, an American mathematician, mathematics is not about numbers, equations, computations, and algorithms. It is about understanding. And we all know if we don't understand math, we can't do maths. So with this, I will introduce you about our keynote speaker, Shri Deepak Vasan, Additional Director at National Institute of Electronics and Information Technology, Ropar. Shri Deepak Vasan, an alumnus of Punjabi University, Patiala, is a postgraduate in physics with electronics as a major. He completed his master's in 1988 and MPhil in the year 1989 from Punjabi University, Patiala. If I talk about his professional journey, he joined erstwhile Regional Computer Center, Chandigarh, in 1989 as a trainee system analyst. Then as a system analyst from 92 to 1997. Then promoted as a senior system analyst from 1998 to 2006. He was promoted as a joint director from 2006 to 2016 at National Institute of Electronics and Information Technology. He was promoted as a director in charge at National Institutes of Electronics and Information Technology, Delhi Center from 2009 to 2011. He was promoted as an additional director from 2016 onwards. And Mr. Vasan is having a more than of 30 years of experience in the area of his expertise. If I talk about the various projects undertaken by Shri Deepak Vasan in the early years, he is a pioneer who worked tirelessly and introduced computerization in various government departments and the organization. He headed the complete process of computerization for the result compilation of Maharishi Dayanand University from 1992 to 1994. He introduced computer-based result evaluation for various entrance examinations conducted by PGI MER Chandigarh. He designed a complete software solution for computerization of Institute of Company Secretaries of India. He undertook the computerization of family living survey done by Ministry of Labour, Government of India. He completed the process for the recruitment of regular teachers in the Government School of Chandigarh from 2002 to 2007. Also undertook the process of recruitment of teachers in Government School of Chandigarh under Sarv Shiksha Abhiyan from 2004 to 2007. He imparted training to students enrolled in DOEA, CCA and B level students in DBMS, Oracle, SAP, software engineering, software project management, software testing and artificial intelligence, and professional business communication. As a director in charge at National Institutes of Electronics and Information Technology, Delhi Center, Shri Deepak Vasan undertook various unique initiatives that helped the Delhi Center in spreading its wings by undertaking various projects of more than 50 departments of Government of Delhi. During his tenure, the center introduced various high-end training programs which were specifically designed for IT professionals working in various government departments. Mr. Vasan was nominated as National Project Coordinator by National Institutes of Electronics and Information Technology for a very prestigious project of National Population Register of Ministry of Home Affairs, Government of India, under which the tremendous demographic data of 62.5 crore population of 17 states and 1 UT was digitized. Mr. Vasan was chosen as a project coordinator for National Council of Promotion of Urdu Language, MHRD, Government of India. And under this program, he started 1-year diploma in computer application, business accounting, and multilingual desktop publishing. Mr. Vasan also designed a 1-year diploma in repair of electronic appliances and maintenance that was offered from 50 Center of NCPUL in 5 states, Delhi, Bihar, UP, Kashmir, and Jharkhand. He was nominated as a Chief Investigating Officer for preparing a detailed project report for setting up of NIELIT Center at UT of Daman and Diu in 2016. As Director in charge at National Institutes of Electronics and Information Technology, Ropar, from 2017 to 2019, under his able leadership, NIELT Ropar signed a memorandum of understanding with IIT Ropar to foster collaboration, provide opportunity for global experience, and to facilitate the advancement of the knowledge. Also, under his leadership, NIE-NIT signed a memorandum of understanding with IKG, Punjab Technical University, employability enhancement training program for imparting summer and industrial training to the students of the university affiliated colleges. Under his able leadership, National Institutes of Electronics and Information Technology Ropar signed a memorandum of understanding with Ratan Bhara Group of Institutes to process the accreditation sought by Ratan Bhara Group of Institutes to run NIE, NIT, NSQF aligned courses which are to be taught as a part of their course curriculum in B vocational and award credits, and to impart the summer training programs and the industrial training program and award credits for the training conducted on its own to the registered students of the Ratan Bhara Group of Institutes. So his achievements and the contribution in the upgradation of the digital system, we can see are commendable, and if I will keep on sharing, it will go on like this. So hence, sir, we are feeling very much privileged today to have you with us. You are an eminent personality in the field of computer science and the electronics. And now I invite you to share your knowledge, idea, and experience with us and with the audience who are watching you live out there in the field of mathematics and interdisciplinary sciences. Sir, please.
Honorable people on the dais, the faculty members, the students who are here or they have connected remotely, I'm so very thankful that I have been given this opportunity to give this keynote address on today's talk, that is Advances in Mathematics and Interdisciplinary Sciences. Special thanks to Ma'am Simarjeet, who gave such a lengthy, I would say, introduction. I'm a very small person. It's just that my age is, I'm already old. I'm already 55. So मेरे को बहुत सारा experience हो गया. It's just that. So I'm a very small person, and see, it's very important that we stay grounded. हम जहाँ पे भी पहुँचे, it's just because of His wish, one up there. वो जो भगवान है ऊपर बैठा हुआ, वही हमें सब कुछ करवाता है. The most important thing in life, I would say, is let us be grounded. There is a small saying in Gurbani which says, "मान ना कीजै, शरण परीजै." मान ना कीजै, शरण परीजै, करे सो भला मनाइए. Whatever he gives opportunity, we should encash those opportunities, and if he has selected, he has bestowed his blessings upon us, we should be eager to take those opportunities and deliver. It's a very special day today, as a matter of fact, when Dr. Satyal and Professor Gandhi contacted me. They're two very, I was told that we are celebrating Mathematics Day, and coincidentally it is 23rd March, which is Martyrs Day, Shaheed Bhagat Singh's Martyrs Day, along with Sukhdev and Rajguru. The third instance or the coincidence, which actually is, these are very trying times. The whole humanity is going through this severe pandemic, and it is not happening only in India, but it is happening worldwide. And the developed and the poor countries, they are all facing the same music. still वो कहते हैं कि साढ़े हाथ तक कर्म है करना. So we should perform our duties. Let's leave it to him. वो अपने आप जो करेगा वो अच्छा ही करेगा, है ना. भाना मनन वाली गल है basically. So we are to celebrate Ramanujan mathematics as well as Shahid Bhagat Singh. What I would do is, first of all, there's this interdisciplinary sciences. This is very appropriate in the sense that I am a physics student. I did my master's and MPhil in physics way back in 86, 88, 89. And my co-speaker, Madam Anita Budhiraja, she's an economics student. And then after joining this office, this was RCC at that point of time, Regional Computer Center. So she did her MCA, MTech, and then we became veterans over a period of time. We were associated with N number of projects, and we were mentoring thousands and thousands of students who undertook training from NILET. You all are aware that NILET is basically National Institute of Electronics and Information Technology, which is the capacity building arm of Ministry of Electronics and Information Technology, Government of India. We provide both formal as well as non-formal education, which is actually one set of activities which we perform. Otherwise, we do total IT solutions, we do large government projects and whatnot. So the experience is varied, and the faculty which is actually imparting this knowledge or training is doing live projects also. So that is a huge advantage, because we carry out computerization of different government departments. And the technology is changing so fast, keeping pace with the technology, adapting with the technology, that requires an effort. I still remember when I was doing, ma'am mentioned that I did MDU's result. आप लोग बहुत छोटे हो गए तब 92, 93, 94 में. तब BA, BSc, BCom Part 1, 2, 3 3 लाख बच्चा होता था जिसके मैं रिजल्ट बनाता था. सॉफ्टवेयर भी लिखता था, डेटा प्रोसेसिंग भी करता था, डेटा कंट्रोल भी करता था, और गजट बुक बन के बाइंड होके बुक शॉप्स पे जाता था. And you would be surprised that we used to work 72 hours at a stretch. Subah, sham, raat, agla din, agli raat. So those were times. I mean, see, nothing is for sure, nothing comes for granted. But मेहनत करनी पड़ती है, which is in our hand. बस हमें मेहनत करनी है, बाकी सब कुछ हो जाता है. So NILET being the capacity building arm, we play a key role in Digital India, Make in India, Skill India initiatives of Government of India, especially when our governing council, the chairman of the GC is Honorable Cabinet Minister Shri Ravi Shankar Prasad, is the chairman of our GC. And MITI like you all know what Arogya Setu is, right? That was taken up overnight by MITI. And now this COVID vaccine that is being, people pan India are to be vaccinated. So that registration is also being done through the software that has been developed by some of the agency of MITI. So these are real-time projects which are actually happening, right? So we have a presence earlier, as I told, this was Regional Computer Center that was set up by Department of Electronics in 1978. Our office was in Sector 17. Then DOIC Society was another body of MITI which was set up for providing non-formal education, which was OAB level courses. And then DOIC CDTI, which was another body which is Center for Electronic Design and Technology. These were merged together and became NILET. This is the history which I've already covered. In 2012, we were given this piece of land at Ropar adjoining IIT Ropar. So our campus is fully functional out there since 2017. And as already been informed that we are into a joint certification training program with IIT Ropar. This is one of the unique initiatives that has been undertaken. You would all appreciate this fact. It's very difficult to get an entry into IIT for all those students who are not students or alumnus of IIT. जो IIT के students नहीं होते उनको entry भी नहीं मिलती है IIT में. But then Dr. Sarit Das, who was the director, and then we had iterative meetings, and then he also thought that this is payback time to the society. Let us give something back to the students of this region. So with that idea, we had started that joint certification training program, which is of great, immense help to the students who are actually going through those training programs. Since it is a day of mathematics which is being celebrated, the appropriate topic in computer science, when I say interdisciplinary sciences, this is one of the most appropriate examples, which is artificial intelligence and machine learning. Very deep knowledge of mathematics is used when we get into machine learning. And all of you know that AI, it is nothing but adding intelligence to the machines. When we add intelligence to the machine, we call that the machine is artificially intelligent. To begin with, when AI was a small branch of computer science, this was way back in 50s and 60s. उस टाइम पे हम वैसे इंटेलिजेंट किसको बोलते हैं? जो एक डिफिकल्ट या बहुत मुश्किल चीज को सॉल्व कर देता है, हम उसको इंटेलिजेंट बोलते हैं, राइट? सो टू बिगिन विद इट वाज थॉट ऑफ कंप्यूटराइजेशन जब शुरू हुई, वी राइट प्रोग्राम्स, we understand the domain, we understand the business logic, क्या फंक्शनैलिटी है उसको समझते हैं, we write program, कोडिंग करते हैं, डेटा को मैनिपुलेट करते हैं, प्रोसेस करके आउटपुट दे देते हैं. That is normal computer programming. But when we say that a machine is capable of applying certain knowledge which it already has and then gives a solution, we say that it has become artificially intelligent. So the aim is transferring this knowledge which is here in my head into the machine, and then let machine takes the decision. That is artificial intelligence, right? So initially when AI was in the very nascent stage, at that point of time, all problem solving, those were the domain areas where people worked. Rich and Knight सबने पढ़ी होगी कंप्यूटर साइंस वालों ने, AI उसी से शुरू होती है. Breadth first, depth first, search techniques and whatnot, goal stack planning. But then this is which has been still programmed. अब उसको कैसे learning capabilities build करनी है? That if a machine gives a wrong result at one given instance, it should have those learning capabilities. It enhances its knowledge and then gives the correct result the very next time. That is the learning. So the next stage of AI, which is these days so very in use, is machine learning. That machine has got these capabilities to learn. You add those facilities or features to the machine that it learns and then gives the results. Machine learning say then the concept and the internally, probably what actually is being used, that these learning capabilities are used, and then that is where this mathematics comes into picture. When decision making is to be done, we have those mathematics algorithms which are fed to the machine. It applies those algorithms and then learns and gives the results. So this slide just shows about the relationship between AI, ML, and DL. AI, which enables a machine to mimic a human behavior. Machine learning is, as I already have said, that it is a subset of AI which uses statistical methods to enable machines to improve with experience. And then we have deep learning, which is further a subset of machine learning, which makes the computation of multi-layer neural networks feasible. Right? At this point, I would invite Anita Budhirajaji to come over and take up the remaining part of the slides, discuss in depth the applicability of mathematical algorithms which are used in machine learning, and then I'll again take over from her. Madam Anita, please.
Good morning, everybody. First of all, I'm really thankful to Riyadh Bara University for inviting on this symposium on advances in mathematics and interdisciplinary sciences. Because in today's date, let me tell you, we are teaching computers. We are into computers for so long. But suddenly, you can say in the last 5 to 10 years, we've seen an eruption that every life sciences or any, you can say even English department people are going into computers. Now, what is the reason behind it? It is only artificial intelligence and machine learning. That nowadays, suddenly the demand of, English professors has just risen, because you all know Alexa, you all know Siri, you all know virtual assistants, you all know those pop-ups coming from the right side of your screen. May I help you? That is all English, that how your sentence can be converted to some logical solution, and it provides you something from the internet. Alexa, Siri will do it from the internet. Your right pop-ups like chatbots, they'll do it from the databases where we have stored all the words. They are going to evaluate and get it. Let me give you one more example. You go to the websites. There on the websites, you want to see that movies, you've seen a movie, you go and put your review on some websites. So those websites where you go and put the review of your movies, that is being picked by so many AI algorithms. What they are doing is they are picking the reviews from there. They are building their corpuses, huge databases. I'm calling them databases. Actually, they're not databases because we are familiar with this term. So they are building all those corpuses, and from the corpuses, they are trying to find out that your review should be treated as being given 4 stars to the movie or 5 stars. So automatically from your text, whatever you type on the internet today, it is being evaluated to some, solution. It can be 4 stars, 3 stars. So just imagine so many people giving their reviews on the internet, and automatically a movie is being given stars based on what you have fed on the internet. Not only this, Twitter analysis, people are tweeting on the internet. So is this tweet a negative tweet or a positive tweet? That is also to be determined. So automatically AI is there. So AI is everywhere. It is embedded in any app you are running on the mobile. Any, you have heard about driverless cars coming, and they have started in US and all, and soon we might see in India also, and they have started. So everywhere, the drones, they are, scanning the agriculture, trying to find out which is the best crop for you, what best we can have in technology, best we can have in production of the cars and all. So what is this machine learning and what is this deep learning? Why suddenly in the last 10 years the boom of this has come up? And every university, you belong to a university, every college, they are starting all these diplomas and degrees in data science, analytics and machine learning. So let me quickly tell you some points where mathematics is required. Now, I am also not from a mathematics background. I did my economics and mathematics, simple graduation. Then I did my master's in economics, but I came into this field quite, in 1993. So when I entered into this computer field, I of course studied so much. I did so many courses I did. Then I did my MTech and many more diplomas also. But we were just, teaching. Sir was also teaching. I was also teaching operating systems, DBMS, and so many things. But in the last few years, people used to ask us, is maths compulsory for doing computers? And we used to say, no, it's okay. You can just do. It's not 100% required. Some degree colleges have kept that you should be maths graduate to enter into an MCA. So, but practically when we used to do the business applications, like let's say I'm making some ticketing system, some railway system, some movie booking system, I don't require any mathematics there. But now when I talk of this data science moving towards machine learning, so machine learning, actually the algorithms which are running in this machine, they are not just simple business applications. They are using the mathematical concepts, which I'll just tell you. Sir has already told you what is machine learning. That machine is learning something. And let me just take 1 more minute to explain you in very simple words, because I think you are all from very varied backgrounds. So supposing I have there's a small child, let's say 6 months child. That child doesn't know this is a dog or a cat. We start telling the child, look, this is a dog. Then the child keeps on growing. He keeps on seeing dogs. We keep on telling him, this is a dog, this is a dog. What happens? His brain starts getting trained. Our brain has got trained that this is a Honda car coming. We recognize it with the, features of the car. We know that this car has a long shape. It is like this. Or this animal is a cow. How does our brain know that? Because we remember the features. Of course, we are very, very, I can say much better than machines, of course. Machine learning is, of course, there, but we have memories. We have so many neurons working in our brains at such a fast pace. But still, what we remember or what a child remembers is, child slowly starts learning. So his brain is trained to those features that a cow is, let's say, 1.5 feet, 2 feet, or let's say 4 feet height. But a dog is only 1 to 1.5. The feature is that the cow has ears like this. So those are the features. So when we do machine learning is that I am making my machine learn on some features. It is very simple. That I'll give my machine 10,000s of records to the machine where the images of, let's say, dogs and cats are stored. So what will the machine do? Machine will pick those images of dogs and cats and do some mathematically algorithm to derive some, let's say, function, simple word, some equation, so that next time it will, whenever I give it some new image of a dog or a cat, it will just put those values in that function and it will tell you that it seems to be a dog. But remember, it is never, may not be 100% correct. Machine learning is all probability. It is just, it takes us to a path. It might be 95% correct, 98% correct. And this is our job, that when you are writing machine learning algorithms, we have to bring it to a point where I'm satisfied with its accuracy. So I keep on optimizing the algorithm. आप उस algorithm को optimize करते रहोगे, better करते रहोगे. Let me tell you, this sir has already told you. So basically machine learning is where the machine is going to learn. From where? From the data. So all of us are hearing these days big data. What is big data? It's just a buzzword. Big data is the huge data which is increasing every day on the internet. You are clicking on a website, you are buying something from an online site, you want to buy a mobile. So when you click there, it shows you people who bought this mobile also bought these mobiles. So that means every click you are doing on the internet, it is being saved. So it can't be saved in Oracle or in SQL Server. It has to be saved in flat files. It has to be saved in an unstructured manner. So it is collecting daily. So in the last 8 to 10 years, 80% of the data which we find on the internet, whether it is Twitter, whether it's social media, your Facebook, Instagram, everything, your oceanic data, your seismic data, earthquakes data, everything. This all data has exponentially grown in the last 10 years. So 80% of the data which is on the internet today has just grown in the last 8 to 10 years. So just imagine how things have changed suddenly. So if we talk about machine learning and then deep learning is just an enhancement of machine learning. It is more of mathematics. So we are talking about maths. It is more of computations, more of mathematics. Why? Because we want to have better accuracy. So if my machine learning model, I give it an image and it detects that it seems to be a cat. Okay, let's say it's image detection. Or you must have been using, children normally do, you bring the app in front of you, it tells you whether you're a man or a woman, a boy or a girl. And anytime it is wrong. Why it is wrong? Because people have just made the algorithm, put it on the internet, not tested it, not seen how much accuracy it is going to give. But when we are in the production environment, let's say a PGI doctor is, from the MRIs of the patients, doctor already has 10 lakh MRIs of the patients. They are stored in the digital form in the computers, in zeros and ones. So images are stored in just pixel points. So just imagine that doctor is going to tell a patient whether he has cancer or not. So to know from the MRI whether the patient has cancer or not, he has already made a machine learning model. He hasn't made it. He is required, doctor is required, domain knowledge is required, a mathematician is required, a computer science person is required. So it is all interdisciplinary today. Everything is required. And like I told you, Alexa, Siri, English people are required. So even chemistry people are required, machine learning and bio. So machine learning is in every field now. So everybody who is making a machine learning model, computer science person cannot do everything. We can't do. I can't do detect whether a person has diabetes from a model. I need to have a doctor who can actually tell me that yes, this BP, this column of hemoglobin is important for determining diabetes. So I have to see what should be my data set, whether I have 1 gigabyte data or I have 10,000 petabytes of data, but that data has to be correct for me to determine whether for a disease or something. Now let me tell you quickly, mathematics of machine learning. Machine learning is a new kind of science, we can say. So science of creating machine programs that improve from experience and interaction. This word is also very important, from experience. So machine learning is improving every day. If supposing a doctor has 10 lakh, records of its patients who have diabetes or don't have diabetes. So there are, let's say, 5 lakh who have diabetes, 5 lakh who do not have diabetes. So he has stored some attributes. Let's say hemoglobin, then it can be your pulse rate, your heart rate and everything. But from that data, he is always using that model to just get a path that whether this person has diabetes or not. The machine is telling him when he inputs the new values of the patient, that this patient has this much pulse rate, this much hemoglobin. But this has to be improved with experience. That means as new patients keep on coming, he'll keep on increasing his data set. So because outliers can exist at any point, you can have extreme values coming. So they are also very important for a mathematician. So actually, if we talk about machine learning or AI, it is a combination of not only mathematics, but statistics also. So there's a lot of debate on this actually. People say that machine learning is glorified statistics. So just go to Google and read about it and you'll find so many interesting, debates on that. Some say no, statistics is compulsory. Some say that how we can say फिर तो statistics institutes बंद हो जाने चाहिए. अगर हम सोचें कि machine learning is just, this, then this is not happening. Because actually it is interdisciplinary. Statistics in itself is something else, dealing with the population and the samples. This is where I need to have extreme values also. I need to have all the data set where I can't ignore the extreme values. But in statistics, we do that. So in machine learning, what is learning basically? What does it mean to understand the world? If we talk about this, what sequence of pixels, like I'm telling you about images, how does a machine know that these pixels, जब आप कोई image store करते हो तो computer में तो pixel store होती है 0101. So how does machine know that these type of pixels means it's an image of a car, it's an image of a cat? So driverless cars is what? The car moving on the road, and car can detect that yes, there's an animal in front of the car. So it has been trained on so many images of cows and dogs and cats that it can easily recognize that the image which is coming in front matches with the data which is already stored in my machines. So this is how machine learning is working. So basically, because all of us are hearing about it, let me tell you something, that if I have to do a machine learning or this project or anything in machine learning, I'll get the data first. Let's say it's a doctor, he'll load the data, he will do some calculations, statistics, standard deviation, means, and your normal distributions, probabilities. He'll summarize the data, then he'll see the graphs. Graphs are the most important part of any data science. You go to Facebook, you go to COVID data, everybody is showing you everything in the form of graphs. Because I don't understand anything from the data. The graphs are the best way to understand. And then we have evaluate some algorithms and making some predictions. So in the machine learning algorithms, we have basically two categories. One is supervised learning algorithm and second is unsupervised learning. Supervised learning algorithm is where we already have data with us. Like I was telling you about diabetes, I already have 10,000 records with me. And I know that out of these 10,000 records, 4,000 records are where the people had diabetes. And 6,000 records are where the people did not have diabetes. So I already have data which is labeled, which has got answers. So I'll ask my machine, learn this data. Learn means do something mathematically. Okay. So it will learn the data. Next time I'll say, now let me enter these values. The pulse rate is this, hemoglobin is this, give me the answer. Machine will say, after learning from this data, see 94% chances that this person has diabetes. This is supervised learning. And most of the work in this world is going in supervised learning. Because unsupervised learning is difficult to achieve. We have algorithms there. People are working on that. Whole Facebook is using unsupervised learning. That I have the data with me. मैं आपको एक 10 लाख रिकॉर्ड्स दे दूं, बट मैं आपको ये ना बताऊं कि इस रिकॉर्ड से कि ये डायबिटीज है कि नहीं है इसको, मैं आपको सिर्फ रिकॉर्ड्स दे दूं. अब आप अपने आप कुछ ढूंढो कि ये वाला पैटर्न्स जो है ये 10 रिकॉर्ड आपस में मिलते हैं. मतलब you don't have the answers and you have to determine from the data the pattern. That is unsupervised learning. It is more difficult to achieve. Now we have fixed algorithms in this. Like in unsupervised learning, we make groups. Facebook automatically makes group of people, जो रात को 10 से 12 बजे तक जस्टिन बीबर के गाने सुनते हैं. तो Facebook ये बता लेता है कि यंगस्टर्स हैं. How Facebook is doing all that? ना वो अपने आप आपको दिखाने लग जाता है. If I know that कि religious songs सुनते हैं, he knows कि ये strata ये वाला होगा. So वो अपने आप patterns determine करके आपका करता है. That is unsupervised learning. So उसमें clustering means grouping. It will automatically do the grouping. Supervised में 2 algorithms है, classification and regression, where I'll tell you in 5 minutes what is maths involved in that. Let us see how maths is involved. Going deeply is beyond the scope of this lecture, but let me tell you quickly what is involved in all this machine learning. We have linear algebra, we have probability theory and statistics, we have multivariate calculus also. Maybe not into so much of depth if I'm doing ML, but for DL I need that. Then algorithms and their complexities. Then many other things also. Like you have done in computer science, your heap sort and your binary search and everything is involved here. Now, linear algebra is required when I have to determine which columns are important, whether pulse rate is important for determining diabetes. You understand these type of things where I have to find the correlation between two columns. I have to find the collinearity. Is this dependent on this column? Can I remove this column? Because the more the columns you have, the more complex your algorithm will be. So we have multivariate calculus, all of you know, I think mathematics people. Then we have algorithms and computer complex optimization and others. So what is the importance of maths and machine learning? Now, whether you are from any field, I think nobody can do without computers. First thing. Second, you can't do without now machine learning also. In another maybe 1 year or you pass out, wherever you'll go, they'll ask you to do some data analytics. Whether you are English student, chemistry, anywhere. So what is the importance of maths in this? So all of you should have good maths. ठीक है, mathematics को हमें भी brush up करने में मुझे भी बहुत time लगा because out of touch, we were not working on that, but it is required. Now, if I have to decide which is the right algorithm for me, there are so many algorithms available. Python is the richest language and the rich in libraries for doing this machine learning. So उसमें इतने algorithms हैं कि आपको decide करना पड़ता है कौन सा algorithm मेरे data के लिए fit बैठेगा. Already algorithms are there, but to optimize the algorithms, I need to know maths. That how can I have more accuracy? How can I improve this? तो आपको mathematically पता होना चाहिए क्या ये average निकाल रहा है, क्या ये neighbors के average निकाल रहा है, how is it doing sum of squares of means, all that. So I'll just give you one example here, the two important things, regression and classification. If we talk of regression is that we are trying to predict the results. आप ऐसे सोचो, if I have to buy a house, आजकल आप internet पे जाते हो, somebody wants to buy a house, he'll put, I want 3 bedrooms, I want a balcony, I want in front of the park, I want this area. So the system वहीं पे बनाता है predict the result. So he'll tell you that you will get a house for 80 lakhs. What is that? It is just taking up the new values from you. It has already learnt the values of the houses, let's say in Ropar and Chandigarh, and it has got tens and lakhs of records with it. So it tries to run that algorithm and tries to find out that for these features, what should be the answer. So it's a probability also. So here when we talk about regression, so it is total maths. I think ये तो एक simple English student को भी 12th तक जो आपने किया हुआ, that you have to draw a line equation. I'll just show you this. All of us know about line equation. Y is equal to C plus M. So this line, I have to draw this line. My machine learning model will draw this line which will be quite close to all the points which are already there for these houses. So here we can see that mathematics is being used. So internally other algorithms देखेंगे, it's all maths. But I can just apply a model also. So if some people are just doing applied machine learning, but you can't do with it if you are actually working in research or you are actually into deployment environment where you are actually doing some production of these things. So in supervised learning, this regression line we have to draw. So that because we have to just make a guess that if this is the data, then let me draw a line which fits all this data. So we have a concept of hypothesis, which is quite linked to statistics also, that I have to, in this line equation, what I have to keep on changing, theta 0 and theta 1. So what will the machine learning algorithm do? It will try with very different values of theta 0 and theta 1 to reach to a solution where you have the minimum error, where you have the minimum cost. This is the formula which is being used, which is the foundation of machine learning. आप machine learning में कोई भी algorithm करो, deep learning में algorithm करो, this is the foundation. That what we have to do is, already जो आपके पास data है, that is the actual results we have. We make a model, I'll use that model on that data. It will predict me the values for those 1 lakh records. मेरे model ने मुझे 1 lakh predictions दी, पुराने data की, पर पुराने data के actual result भी मेरे पास हैं. Actual result minus the predicted result and sum of square. We do it. So it will give me some cost, some errors. कि आपके इसमें error कितना error है. और मेरी कोशिश क्या है, किसी भी analyst की, किसी भी machine learning साइंटिस्ट की कोशिश है इस एरर को कम करना, सो उसको कम करना होता है। देखो इसमें भी मैथ्स है, यू हैव टू ड्रॉ अ बाउंड्री लाइन। अब ये बाउंड्री लाइन बनानी, इसमें आपका एवरीथिंग आई टेल यू, like I have to determine whether this is image is of a cat or a dog, whether this image is of an apple or a banana. So basically I have to draw a boundary line between two objects. Mathematically I have to draw a boundary line. So how do we do it? For logistic regression, which is classification, दो ही चीजें होती हैं, regression and classification. Classification में this is the mathematical function, I think maths people know sigmoid function. So sigmoid function use होता है where the value always remains between 0 and 1. So z function use होता है इसमें and the values will remain between 0 and 1. So it uses the concept of probability also, that either this or this. 70% chances are here, 30% chances are here. So इसमें probability भी use होती है आपकी. So we can see that mathematics is the need of the hour. We need mathematicians. एंड मैथमेटिक्स में जो सेट हो गया था, लोग मैथ्स की तरफ जाते नहीं थे, ऑल ऑफ यू नो, जाते नहीं थे, बड़ी मुश्किल है, ये है, मुश्किल तो अभी भी है, आई डोंट से इजी है, बट सडनली यू नो पीपल फ्रॉम कंप्यूटर साइंस आर टेकिंग एडमिशंस इन मैथमेटिक्स। आप देखो बाहर की कंट्रीज में मैथमेटिक्स की जो यूनिवर्सिटीज मैथमेटिक्स कराती हैं उसमें बहुत रश हो गया। तो आप अगर कोई मैथमेटिक्स के हो, डू मैथमेटिक्स, do statistics, future is yours, next 10 years 20 years सिर्फ यही चलने वाला है। तो आप सबको मैथ्स जिनको इंटरेस्ट नहीं है तो कभी भी नहीं बन सकता मैथ्स, उसमें अगर ऑलरेडी आप मैथ्स के हो तो आपको बहुत इंटरेस्टिंग लगेगा। यू ऑल शुड गो इनटू दिस फील्ड। सो आई थिंक आई जस्ट गिव लास्ट एग्जांपल। नाउ दिस इज बेसिकली अलेक्सा एंड सीरी में जैसे होता है, जस्ट सी आई हैव गिवन अ मूवी रिव्यू, लेट्स से स्लो मूविंग couldn't get into this movie, किसी ने मूवी का रिव्यू दिया, आपने भी इंटरनेट पे जाके मूवी का रिव्यू दे दिया, तो आपकी मूवी के रिव्यू को अपने आप स्कोर्स अलॉट होते हैं, 2.5 1.5, हाउ इट इज बीइंग डन। आप सोचो इंग्लिश की जो डिक्शनरीज है ना, जो थिजोरस है, वो स्टोर किया हुआ पहले, हर वर्ड को एक रेटिंग दी हुई है, सिंपल, हर इंग्लिश के वर्ड को एक रेटिंग है, दिस इज अ नेगेटिव वर्ड, दिस इज अ पॉजिटिव वर्ड। सो हमें इंटरनेट से डाउनलोड ये बहुत कॉर्पसेस मिल जाते हैं, बहुत, आप डाउनलोड करो। एंड नेक्स्ट टाइम दिस टाइप ऑफ इंग्लिश वेयर इंग्लिश इज रिक्वायर्ड, यू कैन सी वी कैन प्रिडिक्ट रेटिंग स्कोर गिवन द टेक्स्ट ऑफ अ न्यू रिव्यू। आपको कोई नया रिव्यू आएगा तो आप उसका अपने आप रेटिंग डिटरमिन हो जाएगी। ओके, सो दिस इज ऑल अबाउट दैट। आई थिंक इवन मतलब अगर 1 लाख वर्ड्स है आपके इंग्लिश डिक्शनरी पे, तो आप लीनियर मॉडल में अगर आप देखोगे तो एक सेंटीमेंट स्कोर दिया जाता है। इसका मैथमेटिकल इक्वेशन मैं आपको दिखाती हूँ, आई थिंक मैंने लिखी होगी, लाइक दिस। सो वी आर बेसिकली डूइंग द सेम थिंग अगेन, दिस इज आल्सो सम ऑफ स्क्वायर ऑफ मीन्स, द स्कोर माइनस द एक्चुअल जो आपका रिजल्ट था और आपके मॉडल ने क्या प्रिडिक्ट किया है, दोनों को हमें कंपेयर करना होता है। एंड देन वी ट्राई टू फाइंड आउट कि मेरा मॉडल कितना ओरिजिनल वैल्यूज के पास है, अगर दूर है तो मुझे उसको बेटर करना। आई हैव टू कीप ऑन रिड्यूसिंग द कॉस्ट। ओके, कॉस्ट रिड्यूस करने के लिए एक और जो फाउंडेशन है इसमें, दैट इज ग्रेडियंट डिसेंट। देयर इज अ कॉन्सेप्ट ऑफ ग्रेडियंट डिसेंट, मैथमेटिक्स वालों को आई थिंक पता होगा ग्रेडियंट डिसेंट। सो ग्रेडियंट डिसेंट इज द लॉजिक वेयर वी कीप ऑन इम्प्रूविंग द लर्निंग रेट। तो हमें मशीन लर्निंग में एक ही हमारा ऑप्टिमम गोल होता है, दैट वी हैव टू गिव द बेस्ट एक्यूरेसी and to have the least cost, and that is all behind the scenes is all mathematics. So gradient descent applied, so I think we have so many algorithms, so I think I will end with this because so we have these algorithms already available in the libraries. I just pick them up, I use them on my data, but to have better results I have to know maths and statistics also. I can't just pick the data, give it to the model, do it and it will give you the result. I can't rely on that. Okay, so thank you so much. So I invite Dr. Deepak Vasan again to say something.
Thank you so much, Anita. We had a wonderful session. आप लोग बोर तो नहीं हुए? I would not get into the nitty-gritties and the complexities of mathematics. I would just end up by saying a few words. We've been talking of AI for almost an hour now, and we've seen how mathematics is important in AI and how the world is changing and how this knowledge is being applied everywhere. So this is the in thing, no doubt. We are trying to impart intelligence to the machines. Whatever we do, one thing we must remember that while adding knowledge or learning capabilities to the machines, we ourselves do not become robots. हम ही heartless या emotionless ना हो जाए. It's just not winning or losing, right or wrong. सिर्फ ये दो चीजें नहीं है जिंदगी में. So it is very important that whatever we do in our lives, whatever our goals are हमारे हाथ में क्या है? सिर्फ effort. वो हमें best put in करना है. अगर मेरे को एक मशीन को नॉलेज देनी है तो दैट इज माय जॉब, पर मैं खुद मशीन नहीं बनना चाहिए. दैट इज वेरी इंपॉर्टेंट फॉर ऑल द यंग स्टूडेंट्स हु आर एस्पायरिंग टू बिकम somebody one day. यू नो, वो जो पीक पे जब जो भी मेरा गोल है अगर मैं उसको अचीव कर लेता हूँ, पीक इज ऑलवेज वेरी लोनली. पीक इज ऑलवेज वेरी लोनली. आप अकेले हो जाते हो. जो पाथ है, जो जर्नी है टू अचीव दैट पीक, वो आज है. जो जर्नी हम ट्रेवल कर रहे हैं, दैट इज द जर्नी विच वी रियली हैव टू एंजॉय एंड सी व्हाट इज, हम इस दुनिया में आए क्यों हैं, व्हाट इज आवर लार्जर एम इन लाइफ. इट इज जस्ट नॉट टू सक्सीड इन लाइफ. It is making sure that while I succeed, मेरे peers जो मेरे colleagues हैं वो भी succeed करें. So it's always a team that wins or loses, not an individual. I would mention a very recent incident. पीछे ऑस्ट्रेलिया में टेस्ट सीरीज हुई थी. गेम्स का शौक होगा कईयों को. तो इंडिया was in real bad state. हम मैच हारने वाले थे जब रविचंद्र अश्विन और वॉशिंगटन सुंदर ने खड़े होके मैच संभाला था. एंड अल्टीमेटली वी वन दैट मैच. अश्विन से पूछा गया कि हाउ वाज ही फीलिंग एट दैट पॉइंट ऑफ टाइम आफ्टर व्हेन ही वाज अवॉर्डेड दिस मैन ऑफ द मैच अवार्ड. ही सेड, आई हैव नो फीलिंग्स, आई हैव नो इमोशंस, आई डू नॉट नो कि क्या हो रहा है. सो दैट पीक, दैट मोमेंट ऑफ सक्सेस, इट इज लोनली. उस टाइम एक्चुअली कोई फीलिंग्स नहीं होती हैं, बट वो जो जर्नी है, बॉल्स खाई, इतना मुश्किल से उसने दिन निकाला, बट देन वी सक्सीड, वो मैच जीते. एंड सिमिलरली व्हाटएवर वी आर ट्राइंग टू डू, व्हाटएवर वी आर एस्पायरिंग टू बिकम, एक जेंटलमैन वे से अच्छा इंसान बन के सबको साथ लेके, जेलसीज का कोई फायदा नहीं होता, पीयर प्रेशर्स, पीयर ग्रुप्स का कोई फायदा नहीं होता. These are all very material things. Ultimately जिंदगी में और बहुत सारा कुछ है. So I would really request all students, especially जो आज की young brigade है, life is not winning or losing. It is something different. Whatever we are able to give to the society, वो जो सेटिस्फेक्शन है, सबसे ज्यादा खुशी वही है सेटिस्फेक्शन जब आप किसी को कुछ देते हो. कुछ पाके कुछ ज्यादा खुशी नहीं मिलती. जब आप किसी को देते हो, then you feel satisfied, and that is the internal and the real happiness which matters. One more thing जो मैं बात करनी चाहूंगा आज की डेट में, especially the social media. बहुत सारे झूठ सच सोशल मीडिया पे चलते रहते हैं. We should not be affected by those half truths. हम सब पढ़े लिखे लोग हैं, अपना हमारा दिमाग है, तो whatever information or the knowledge is being given to us through this social media drive, वो हमें प्रोसेस करनी है और हमें देखना है वो ठीक भी है या नहीं, फैक्ट फाइंडिंग कर लेनी चाहिए. That is very important. Thank you so much once again to the Riyadh Bara group who has invited us on this talk. I would see that we can have further meetings with the Riyadh Bara University management, wherein the students of this college or the university can benefit from the training programs which we impart. Thank you so very much once again. Thanks a lot.
Thank you so much, sir, for your thoughts.
Now, to enlighten more on mathematics applications, we would like to invite Head Department of Mathematics, Dr. C.P. Gandhi sir, on the stage.
Thank you, students. Okay. Good afternoon to all of you. Esteemed our keynote speaker, Dr. Deepak Vasan, Madam Anita, thanks for your coming here. Now I will try to apply mathematics in real applications. We can apply mathematics to almost every branches of sciences, engineering, for example, in mechanical, civil engineering. We are all familiar with some famous differential equations like Legendre differential equation, Bessel, Hermite, Laguerre, Chibachevsky differential equation. These differential equations have wide applications in engineering. For example, the solutions of Legendre differential equation can be used to study harmonic function in complex potential theory. These solutions can also be used to solve Laplace equation in spherical polar coordinates. Similarly, the solutions of Bessel differential equation can be used to solve Laplace equation in cylindrical polar coordinates. There is one more differential equation, that is Coulombic-Schrödinger equation. We use this equation in quantum mechanics. Now, quantum mechanics is a branch of mechanics that deals with mathematical description of the motion and interaction within subatomic particles. Now, from this equation, The symbol E is for total energy of the system. VR is Coulomb potential energy. It admits continuous state if E is positive and discrete bound state if E is negative. Here Z is the number of protons in a hydrogenic atom. Now what is hydrogenic atom? This atom consists of 1 electron and Z protons. If Z equal to 1, then this atom becomes hydrogen atom. When Z equal to 2, this atom becomes ionized helium atom. When Z equal to 3, this atom becomes double ionized helium atom, and so on. Here we restrict the case when E is negative. So we can apply mathematics to solve this equation. Although many physicists and chemists had applied to solve this equation, but they were not from pure mathematics. Here we have tried to solve this equation by applying Frobenius method. Now Frobenius method is a powerful tool to solve those differential equations which we can't solve by our existing methods. In existing methods, what we do, we find complementary function, particular integral, but it is always not possible to solve a given equation by this method. So in that case, Frobenius method is the best tool. So I have applied Frobenius method to find the explicit representation of the two linearly independent solution of this equation, as shown here. Now this equation is very complicated, but we have obtained it by applying the Frobenius method. This function is used to determine the energy level in a hydrogenic atom. The factor 2Z R by eta A determines the behavior of this radial wave function of the first kind for a given L. L means angular momentum quantum number. Now when L increases, what will happen? When L increases, this radial wave function gets pushed away from the origin. This is a concept proved by some physicists, but we have tried to prove this concept by applying mathematics. You can also see this function R is localized by the factor E minus Z R by eta A. When Z increases, I mean when the number of protons are increased, then this radial wave function gets pulled into the origin. We will also prove this by applying pure mathematics, not from physics or chemistry point of view. Similarly, when eta is principal quantum number. When this number increases, this function gets spread out. But we will prove this concept by applying pure mathematics. Similarly, you can see the second power series solution of the Coulombic-Schrödinger equation. Now, this is very complicated infinite series. I tried to find the graphs manually, but it was very difficult task for me. So I took some help from computer science engineers. He taught me how to use Mathematica. So with the help of Mathematica, I obtained this graphical representation of this wave function. Now, first function is regular because there is no logarithm term. But second function is irregular because of the presence of the term log r. Now I wanted to discuss the behavior of the solutions. Otherwise, there is no use of solving a differential equation if we don't have any applications of the solutions. So with the help of Mathematica as well as mathematically, I obtained the solution for eta equal to 1. When I say eta 1, it means ground state or lower state of energy. When I take L0, it means there is no angular displacement of the radial wave function. So we have plotted this graph with the help of Mathematica for eta equal to 1. Similarly, for eta equal to 2, we have obtained mathematical expressions of these functions for eta equal to 3, 4, and so on. Now, all these are infinite series. We don't know whether these series are convergent or divergent, but we expect that these series should be convergent. So to prove this fact, we again took the help of Mathematica and plot their graphical representations as shown in figure 3 and 4. Similarly, for other values of theta, eta, we can see these graphs like here. Now we try to discuss the behavior of the solutions. Now you can see from this graph, when the number of protons in a hydrogenic atom increases, what would happen? The radial wave function gets pulled into the origin, but they are coming back to the origin when the number of protons are increased. Similarly, when angular momentum quantum number increases, then what happens? These functions are getting pushed away from the origin. Similarly, when eta increases, this function gets spread out. So all these concepts we have proved by applying pure mathematics as well as with the help of Mathematica. We conclude about this equation that both the regular and irregular solutions of the Schrodinger equation get spread out in their distribution whenever system energy increases from negative values to 0. So we have seen we can apply mathematics to physics. We can also apply mathematics to mechanical engineering. For example, first of all, what we need to do? We need to collect vibration data of rolling bearing. Then we can decompose the data by means of any form of transformation like wavelet transformation, Fourier transformation, discrete wavelet transformation. Then comes maximal overlap, discrete wavelet transformation. This decomposition was possible only because of mathematics of transformation. After decomposing the transformation of signals, we extracted the lower and upper energy bond of each testing and training sample. Then we constructed the energy interval ranges. Then our mathematics starts at this point. What we did? We converted the energy interval ranges into the form of fuzzy sets or single valued neutosophic sets or neutosophic cubic sets. There are so many Please give a big hand. So I was telling you, we can construct fuzzy sets, single value neutosophic sets of each training and testing sample. Then between these two sets, for example, we can take single valued neutosophic sets. We can find the minimum cross entropy value between each sample. Then based upon the minimum value, we can identify faults of a rolling bearing. For example, this graph was not possible in Excel or Word. Only because of Mathematica, we were able to plot this graph. Now you can see on left hand side, these are 5 testing samples, FT1, FT2, FT3, up to 5. And on the right hand side, these are defect conditions of a rolling bearing. For example, defect free conditions, or you can say normal bearing, then unbalanced, rub, parallel misalignment of 7 mils or 10 mils, and angular misalignment of again 7 mils or 10 mils. So by finding the minimum value of cross entropy between the testing and training samples, we have identified the faults. Now the red pillars are identifying that we have actually find the fault. When we performed the experiment with the help of mechanical engineers, our results were totally matched. So this is how you can see we can apply mathematics to almost every branches of mathematics, like engineering, civil engineering, mechanical engineering. Thank you.
Thank you so much, sir. As we know that today is 23rd of March and each year on this day, homage is paid to the great revolutionary freedom fighter Shahid Bhagat Singh, Rajguru and Sukhdev, who sacrificed their life for the freedom of our country.
Now, we would like to invite the Registrar Sir of Riyadh Bhara University, Dr. B.S. Satyal Sir, to talk more about on Martyrs Day.
Thank you, students. The chief guest of today's function, Dr. Deepak Vasan, my good friend since 1980s, Joint and Deputy Director, Additional Director, NILETS, Madam Anita Budirajaji, Joint Director, NILETS, Roper, Dr. C.P. Gandhi ji, HOD, Mathematics Department, Dr. Simar, Head of the Life Sciences Department, Dr. Ravneet, Dr. Pooja, my other colleagues, Madam Sakshi from library, students, faculty members, and those who are online with us. I congratulate all of you for celebrating the National Mathematics Day 2019. And as you have been told that today is a day to remember our great martyrs. Before I move over to the Martyrdom Day, I should thank Deepak ji for accepting our invitation on the request of our Vice Chancellor, worthy Dr. Parvinder Singh ji. During my teaching days, I have been telling the students that one who is good in physics is supposed to be good in everything. Deepak is a living example of this. Apart from physics, he is good in administration, good in computers, good in mathematics, good in family relations, because I know him. He has a very fine, happy family life, good as friend, and overall good as a human being. So thank you, Deepak ji. So this is Rajbara University. Coming to the Martyrdom Day, we all know that Sardar Bhagat Singh, along with his comrades Rajguru and Sukhdev, they were all sentenced to death on this very day 90 years ago. That is on 1931. And Bhagat Singh was just 23 years of age. And not only in India, but everywhere in the world, we know him as India's greatest revolutionary freedom fighter. His actions inspired the youth of the nation to fight for the nation's freedom. Born on 27th September 1907, in a family in which his father and uncles were members of the Gadar party led by Kartar Singh Saraba and Lala Hardayal. His initial schooling was in JV School, Lahore, and because of his schooling, he was more inclined to the Arya Samaj philosophy and was greatly influenced by the teachings of Swami Dayanand ji. He was very young, say in 1919, he was just 12 years of old when the unfortunate massacre in Jallianwala Bagh occurred. And since I told you that he belonged to the family of freedom fighters, when he was born, his uncle was in the jail. His paternal uncle, his father was also in jail. His paternal uncle was in America forming Gadar party with Lala Hardayal. So he visited the site of Jallianwala Bagh at a very young age of just 12 years. In 1921, two years after that, the unfortunate Nankana Sahib massacre took place in Lahore, near Lahore, when hundreds of unfortunate people from Punjab were massacred by the forces of the British police. He, in his village, organized the Langar Seva. He was part of that, the persons who were used to go to the Satyagraha. He used to distribute langar to the protesters and go to the railway stations, stop the train, and would provide the free langar seva at a very young, tender age of 14 years. So you can just visualize the spirit he had right from the day when he was in school or very young. And in 1923, after passing from school, he joined National College in Lahore, where he was very regular in participating in the extracurricular activities organized by the college authorities. He took part in dramatics club, he took part in extempore speeches, and the history says that he used to win many prizes in those events. And while in school, college, in 1926, he founded Naujawan Bharat Sabha in March 1926 and joined Hindustan Republican Association and left home because his family wanted that he should marry, but he said that I will not marry. I am for the much greater cause. I will fight for the freedom of the India. And without informing his family, he left home for Kanpur to meet other revolutionaries of India like Chandrasekhar Azad, Bismil, Ram Prasad Bismil, and Shahid Asfaqullah Khan. He, along with Sukhdev, planned to avenge the death of Lala Lajpat Rai ji, who was killed by the British, who died because of the injuries he had when he was struggling against the Simon Commission report. So he plotted to kill James Scott in Lahore. However, in the case of mistaken identity, he couldn't find Scott and killed another person from police. He was Assistant Superintendent Police John Saunders. He was shot. And later on, with Bhakteshwar Dutt, he threw bombs in the Central Assembly Hall in Delhi. And shouting the Inqilab Zindabad slogans, he did not resist his arrest and happily courted arrest. He was imprisoned. And at the time of his trial, he didn't offer any defense because he didn't believe in the government of England or the United Kingdom. And rather, he used the occasion to propagate the idea of India's freedom movement. He even went on to Satyagraha in the jail for the better lives of the prisoners. He used to say that I'm not an ordinary prisoner, but a political prisoner. I'm fighting for the cause of India's freedom. And when one of our freedom fighters died in this Satyagraha, even Pandit Jawaharlal Nehru also visited him in the jail. Finally, on 23rd March 1931, along with Rajguru and Sukhdev, he was hanged. Actually, the date was 24th March, but the Britishers were so scared of his hanging that he was hanged a day earlier than the announced date. And Bhagat Singh's hanging brought mixed emotions throughout India. Mahatma Gandhi felt that he was too radical and heard the quest for freedom while Pandit Nehru met him in the jail when he was on a hunger strike. And as I told you, just after meeting Shahid Bhagat Singh in the jail, Pandit Jawaharlal Nehru stated that I was much pained to see the distress of the heroes in the jail. That these heroes have staked their lives in the freedom struggle. They warned that political prisoners should be treated as political prisoners, and Nehru said that I am quite hopeful that their sacrifice would be crowned with success. Muhammad Ali Jinnah, who was at the time in Congress party, defended his actions. Subhash Chandra Bose, the greatest freedom fighter of India, said that Bhagat Singh had become the symbol of the new awakening among the youths. And just see the popularity of Bhagat Singh in those days, that 4 years after his death, the then director of Intelligence Bureau of England, Mr. Williamson, he writes, just see the popularity of this man, Bhagat Singh. After 4 years of his death, that is in 1935, he says his photograph was on sale in every city and township of India, and for a time rivaled in popularity even that of Mahatma Gandhi. In 1935, his stature was much ahead of our most popular leader, who was later to become father of nation, Mahatma Gandhi. So British man is writing about Bhagat Singh. And we all know that the youth of India still draw tremendous amount of inspiration from Bhagat Singh's life. A few years back, he was voted the greatest Indian in a poll conducted by the Indian magazine India Today in 2008. This poll included Subhash Chandra Bose and Mahatma Gandhi, Jawaharlal Nehru also. But Shahid Bhagat Singh tops the list of the greatest Indians in that poll. So you can well visualize the philosophy which Bhagat Singh has given to us in just 23 years. Not only he was popular in North India, even in Tamil Nadu, the farthest most state of India, Periyar Ramasamy, who we all know is the founder of Dravidra Kazhagam, he was a very popular leader of Tamil Nadu who formed Dravidra Kazhagam, which later on became Dravidra Munnetra Kazhagam, and later on its offshoot became All India Anna Dravidra Munnetra Kazhagam. So all the Dravidya movement took place because of Periyar Ramaswamy. He used to edit one newspaper in Tamil Nadu, and on 29th March 1931, 5 days after the execution of Shahid Bhagat Singh, Rajguru and Sukhdev, he writes an editorial. Just listen to the lines written by the great Periyar. He says, Bhagat Singh gave his life for the noble cause of showing to India the path of real equality and peace. He has reached a great height, a feat never achieved normally by anyone else. We in Tamil Nadu applaud and sing of his martyrdom. So you can understand the gravity of the actions, deeds taken by this great man, Shahid Bhagat Singh Ji. So to conclude, because the time is short, we can speak endlessly on his ideas. He was a great reader also. He used to read books. Even in jail, he used to call the people from the library of the Lahore, and many librarians visited Bhagat Singh's jail to give him the books. He was fond of reading books. He was a socialist revolutionary whose acts for freedom struggle against the British in India and his execution at this young age of 23 made him a folk hero of Indian independence movement. On this day, we in Rajbara University salute to these three great martyrs, Bhagat Singh, Rajguru, and Sukhdev. Thank you.
Thank you so much, sir. Now we would like to request the Registrar Sir, Dr. B.S. Satyal Sir, and the Head of Mathematics Department, Dr. C.P. Gandhi Sir, to present our keynote speakers with the memento as an expression of our gratitude.
Thank you so much, sir. Now, we will request our beloved Head of Life Science Department, Dr. Simarjit Ma'am, to come on the stage for the vote of thanks to our guest.
A very good afternoon, everyone. Such an enlightening and mind-boggling session. I never thought mathematics could be so much interesting. Thank you for making it so interesting and so magical. So on behalf of Ratan Bhara University, we are very much grateful to our worthy Vice Chancellor, Professor Dr. Parvinder Singh, for his kind approval for the conduct of this National Mathematics Day. We are very much thankful to Professor B.S. Satyal, Registrar, Ratan Bhara University, for his continuous support and guidance and sharing his thoughts on interdisciplinary approach of mathematics. And also, sir, we are very much thankful to you for sharing this emotional, journey of freedom of Shaheed Bhagat Singh, Rajguru, and Sukhdev on their Shahidi Divas. Thank you very much for these emotional moments. And a very special thanks to our esteemed keynote speaker, Dr. Deepak Vasan, Additional Director, National Institute of Electronics and Information Technology, for sharing his valuable time and enlightening us about the interdisciplinary nature of mathematics in artificial intelligence and machine learning. And sir, most importantly, motivating our young minds to take their knowledge for the benefit of the society and to stay humbled and grounded no matter what peak we achieve in our life. So thank you very much, Dr. Vasan, for imparting quality knowledge as well with our young minds. Thank you very much. We are very much thankful to Dr. Anita, National Institutes of Electronics and Information Technology, for sharing her views on the role of mathematics in computer application by citing day-to-day examples for the better understanding of our viewers in the field of machine learning. Thank you so very much, ma'am, for sharing your knowledge and expertise with us. We are thankful to Dr. C.P. Gandhi, Head of the Department Mathematics, about his informative talk about pure mathematics. So he knows how to be a real mathematician and the magicians. I'm thankful to Professor Ravneet, Professor Rohit, and our dear students, Neha and Arshdeep for wonderful job for the successful conductance of this event. So thank you very much. Last but not the least, we are very, very much thankful to all our heads of the department, Dr. Sakshi, Dr. Pooja, Anshu ma'am, all faculty members, and of course, our very dear students for joining us today for this special events to celebrate National Mathematics Day. Though we delayed this event due to COVID-19, but still the results are very much productive and very much fruitful. Thank you very much, everyone. God bless you all. Stay safe, stay blessed. Thank you very much.